example. Right? And if you look at this, what do you see? What's the difference between the two? So the exponent is for both in which one? In the first one. So you see that this subtract 2 is under the square, right? So technically speaking, if I'm going to do my bed mass here, I have to evaluate the x minus 2 first, then square, right? While in this case, if I'm going to do bed mass, I have to do the exponent first, then subtract, okay? Well, again, here, I have to do first, then I have to square, okay? So the difference is whatever's inside the bracket is going to affect the x value, okay? Because it's with the x under the square, okay? So I am not going to ask you to, well, let's see. What do you think is going to happen if I add or subtract things inside the bracket with the x? It's going to shift it horizontally. And why horizontally? Because it's the x, right? If you guys remember the x, so this is the y, that's vertically, right? This is the x, and that's horizontally, right? So if it's affecting the x, it's going to affect it horizontally because that's what the x is, okay? Now let's see how that's going to work. So we're going to go back to Desmos, and then we're going to put these functions in Desmos, and let's see what happens. Okay, again, we're comparing it to y equals x squared. So the first one is y equals bracket x minus 2 close bracket, and then put the square. All right, what happened here? Which way did it shift? That way is what?
1 over horizontally.
Okay,
So x 1.
no, it's 2. But which way?
Right.
2 to the
Right.
right. So it shifted 2 units to the right. Okay? What was my function again? Y equals x minus 2 squared. It shifted 2 units to the right. Is that a coincidence? Is that something that, did you expect that? What did you expect it to go? Do you think it's going to always happen if I'm subtracting 2? If I'm subtracting a number, is it going to always happen to the right? Yes. Okay? So, you see this value right here? This value here, we call that the h, okay? And then it's in the equation, it's x minus h squared, okay? Now, because this stays a minus, so I have x minus 2 squared, because this stayed a minus, it did not change, that means my h value is 2, okay? So since my h value is 2, 2 means positive 2. Okay, which that's why it's moving 2 to the right. Okay? What if your h is negative? What happens? So if h is negative, what happens? I have negative, and then negative, whatever, 3, let's say. Okay? So if I have a negative and a negative, what's going to happen there? It's going to be a positive, so it's going to look like this. Okay? So if h is positive, then it's going to look negative in the equation. Because that negative is already in my equation. That negative, if you look in this vertex form, we're going to talk about this later. But if you look in my equation, there's already a negative. Okay? If h is positive times a negative, that stays a negative. If h is a negative, negative and negative makes it a positive. So that's why it's opposite to what you see, because you already have that negative here. Okay? So, give me the second, actually, what's the vertex here? What's the vertex? 2, 0? 2, 0. Okay. What is my, yeah?
When you say the vertex, we can't say only two?
No,
We have
vertex
to
is
say-
a point.
Yes, but we can't say two.
Nope.
And
Nope.
exemplary, no?
Nope. A vertex is a point. You have to include x and y value.
How I know now, I can't see now, it says there is two, but how I know it is x is or y is two when I write that?
X is 2, y is 0.
Okay, depend on the graph, where the graph is.
That's right. So if you look at this point here, the x is 2, the y is 0. The y is 0 because it's on the x-axis. So you see that this is your y-axis, right? And the y is 0 here. Okay? When you're including a vertex has to be a point. If you don't give me the x and the y value, I'm going to give you a big fat O. Means 0. Okay? Do I need to repeat that?
No.
All right. Now, if I'm looking at the vertex, it's 2, 0. So that movement affected my x value, right? The x value of the vertex. Now, how about the opening? Still up? Perfect. Now, how about your axis of symmetry? Move to 2, right? Remember that your axis of symmetry is the x value of your vertex. Okay? Now, what's the second equation that we're looking at? Y equals what? That's not the equation. Y equals bracket
Squared.
minus 4 close bracket squared. All right. So what do we have here? Can someone describe this to me? So if we describe the other one as vertical translation, how can we describe this? Horizontal translation. Perfect. Now if I'm going to describe this, I'm going to say horizontal translation, 4 units to the right. What's my vertex? 4, 0. What's the axis of symmetry? X equals 4. All right. Now, the next is going to be x plus 1 squared. So since it's x plus 1 squared, which way do you think it's going to move? To the left. Okay, I'm going to remind you that my equation is x minus h squared. Okay? Now, if my h is negative, so I'm going to get x minus and another minus. Okay? So what happened here is the minus and the minus force it to become a plus. And that's why it's technically to the left. That's why when it's a positive, it's actually to the left. Okay? So let's see. So y equals to, open bracket, x plus 1 close bracket squared. So we see that, you see the blue graph? Okay? So I have a horizontal translation, 1 unit to the left. y equals x squared. So you see that it has moved 1 unit to the left, and my vertex is negative 1, 0. So, if you guys look at this, to determine the value of h, remove it from the brackets by setting the expression equal to 0 and solving. So basically what this is telling you is, to know what h is, it's the opposite sign. Opposite sign. So, in this case, h is what? 2. In this case, h is, how about in this one? Negative 1. So it's the opposite to what your eyes see. And this one? Negative 3. How about the direction of opening of all of them? All up. Remember, only A affects your direction of opening. How about the vertex? 2, 0.